Hey friends, today we're going to talk about dividing by multiples of 10, and we're going to do a few of these problems together. Now remember, for each of these assignments, there's a video on Envisions that goes with it, along with the digital quick check. So when you're on Envisions, the video says visual learning, and then it says the name of the lesson. Now we're going to divide 1,467 divided by 20. Now we've learned a couple of different strategies for division so far. We've learned an area model strategy where you draw a big rectangle that represents your 1,467 and then divide it up into groups of 20. We've learned partial quotients, which is where you kind of make a long tail on the side of your division problem, and then you repeatedly subtract partial quotients by multiplying up until you get your answer. And then we've learned what I would call the traditional algorithm. Now, an algorithm is a set of steps that you use to solve a problem where the steps are the same every single time. So the traditional algorithm, or the US algorithm, is first you divide, then you multiply, then you subtract, then you compare and bring down, and then you repeat. That's the US algorithm that probably your parents learned in school. And the steps are always the same. If you get the steps out of order, you won't get the right answer. So you should choose the strategy that works best for you at this point. Okay, now yesterday I mentioned in one of my videos that sometimes it's helpful to do what we call a brain dump when you're beginning a problem like this. And a brain dump is just where you start kind of playing around with the numbers and see what you know about these numbers. This can help you think about compatible numbers as well as what kind of an estimate you might be looking at. I also like to imagine some kind of story to go with the numbers, and that helps me make sense of the problem and double check to make sure that my answer is reasonable. So I'm going to pretend that I have $1,467 saved up, and I'm going to share that money with 20 of my best friends. I don't know why, I just always use the same story problem with sharing money because it helps me make sense of the problem. So I'm going to start by imagining that I gave each one of my 20 friends $5, which means I would be sharing $100. And look, I still have way more money than that to share. So I could move up and go ahead and share $10 with each of my 20 friends, and that would be sharing $200. And I still have way more money than that to share. I have $1,467. So let me go ahead and give each of my 20 friends $50. That would mean I had shared $1,000. So this tells me that I could probably give my friends maybe somewhere between $60 and $70 each. That's going to be my estimate. I'm going to put E for estimate there. Okay, now I'm going to go ahead and divide and see what I get. And I'm going to show you, I'm going to model this problem with the traditional algorithm, which is where you divide, multiply, subtract, compare, and bring down. Okay, so we're going to start by saying how many times does 20 go into 1? Of course, we can't do that because 1 divided by 20 will give us a fraction or a decimal. Then we're going to say how many times does 20 go into 14? Can't do that either. So we need to divide how many times does 20 go into 146. Since we're starting all the way over at our hundreds place, that's where I'm going to put the first digit of my quotient. So 146 divided by 20 is going to be, I want to say 5. No, I could do 6, 7, yeah, okay. So that's my division. 7 times 20, now I'm going to multiply. 7 times 20 is 140. That's my multiplication. Now I'm going to subtract. 146 minus 140 is 6. Now I need to compare. 6 is less than my divisor, so I can move on.
Miss Lynn?
Now I'm going to bring down my 7. Next, we'll figure out how many times 20 goes into 67. 20 times 3 is 60, so I can do 3 up here for my quotient. 3 times 20 is 60. Subtract. And I have a remainder of 7. Since 7 is less than 20, I know I can stop there. And I can put my remainder either like this, or I can express it as a fraction. Okay, for this next problem, I'm going to demonstrate how to solve it using an area model. Now, the purpose of an area model is to help you visualize your whole, which is your dividend. So in this case, our whole is 6,485, and we're sharing that into 90 groups, and we're trying to figure out how many are in each group. So the example that I always go to is I just imagine, okay, I'm sharing $6,485 with 90 of my closest friends. I've got 90 people lined up in front of me with their hands outstretched, waiting for their money, and I need to figure out how much money each one of them can get. So the area model helps us to multiply up times our divisor until we've given out all of our money. So you multiply up and then repeatedly subtract your partial quotients until you can't go anymore. Now don't forget that compatible numbers are going to help you with this process. So when I look at these numbers, and I tend to just keep a multiplication chart handy, I know that 9 times 7 equals 63, which is awfully close to 64. So that means that 90 times 70 must be 6,300. So that's like saying, okay, I've given $70 to each of my closest 90 friends, and so I've passed out $6,300 so far. So now I need to take that amount and subtract it from my total so that I can see how much money I still have left to share. So I can see I have $185 left to share. Now again, remembering compatible numbers are going to help you here. 9 times 2 equals 18, which means 90 times 2 is 180. So that would be like saying, okay, 90 closest friends, you can each have $2 more. So now you've shared out, you've got $185 left, and you've passed out 180 of that. You only have $5 left. Pretty much out of money now to share. So each of your 90 closest friends has gotten $72 with a remainder of $5 left over. And you can also express that as a mixed number. Each of your closest friends has gotten $72 and 5/90ths are left over. Meaning you could carry on splitting up that money, since money is something that can be, you can continue to break it down into smaller pieces. And so you can express your remainder as a fraction, and you can even go a step further and reduce this fraction. I don't know if that's something you learned in 4th grade, because 5 and 90 both have a factor in common, which is 5. So I can divide both the numerator and the denominator, by 5, and that will give me 1/18. So 72 and 1/18. But this is also perfectly correct. This is perfectly correct, or you can reduce the fraction and that would be correct as well. Okay, for this next problem, we're going to be making an estimate. To drive from New York City, New York to Los Angeles, California, you must drive about 2,779 miles. If you drive 60 miles per hour, about how many hours would you spend driving? So we're going to take our total mileage for that very long trip and split it amongst our speed, which is 60 miles per hour, and see approximately what we get. So I can use my little squiggle equals sign to show that this is just an estimate. So now we're going to need to come up with some compatible numbers to help us divide easily. I think for this problem, an area model can also help us because we can use our big rectangle to represent the mileage that we're going. And then the 60 miles per hour will help us multiply up to get to our dividend, 2,779. So let's start by multiplying. Let's do 60 times 40. So I can multiply my non-zero digits first, which are 6 and 4, gives me 24. And then count up my zeros. I have 1, 2 zeros, so I need to have 2 zeros on this side. Okay, so that gives me 2,400. So 2,779 minus the 2,400 miles I've already driven in 40 hours leaves me with 379 miles left to go. So now I'm going to multiply 60 times, 60 times 4 would give me 240 more miles. So that would be 4 more hours of driving. So 379 minus 240 miles. Okay, now I've got 132 miles left to go. Kind of ran out of space here. Whoopsies. All right, so now I can do 60 times 2, so 2 more hours of driving. That would get me to 120 miles. All right, now I've just got 12 more miles left to go. So let's see, how many miles, or how many hours did I drive? 40 hours, 4 hours, and 2 hours gives me 46 hours with a remainder of 12 more miles left to go. So that means that we are going to be going about 47 hours. So remember how last week when we were talking about division, we said, well, you have to make a decision about what you're going to do with your remainder. So sometimes when you have a remainder, the logical option is to round up. Like in this case, you're going to spend more than 46 hours driving because of this little remainder of mileage that you still need to go. So we round up to 47 hours. Next, we're going to work on a field trip word problem. And I have worked with students on a lot of problems that deal with kids on a bus, and they always get confused with this. So this is another good example of what to do with your remainder. A group of 483 students is taking a field trip. 1 bus is needed for every 50 students. How many buses are needed? Now, the mistake that most kids make when they're solving this problem, or problems like this, is that they go ahead and divide, and then they get their remainder, which is like a certain number of kids that can't fit on a bus, and they just leave those kids behind and don't get them an extra bus. So this is another example of a problem where when you have your remainder, you do need to round up so that every child can get on a bus and go on the field trip. So our total, our big rectangle here, is going to represent 483 students taking the field trip. And we're going to multiply up by 50 students to make sure that everybody can get on a bus. So 50 students times, let's see, we could do, if we do 8 buses, 50 students times 8 buses, that would be 400 students that are on those 8 buses. So that means that, oh gosh. So that means that 83 students still need to get on a bus. So let's get 50 students on another bus. Okay, so we've loaded another 50 students onto a bus. That leaves us with 33 more kids standing around wondering if they're going to get to go on this field trip. So don't be like your 5th grade friends who just leave their classmates behind. Instead, we need to get one more bus for those remaining 33 kids. So remember when I talked to you about the difference between the mathematical answer and the problem answer? In this case, the mathematical answer is 483 divided by 50 equals 9 with a remainder of 33. But our real world answer is we need 10 buses. And then you need to explain why you need 10 buses. You need 9 buses, each full, completely full with 50 kids each, and then one more bus that will only be partially full with 33 kids in that one.